This quiz tutorial is on problem 16.P.43, so please refer to the problem in the text to follow along. This is the diagram included with the problem. The problem reads, a thin-walled hollow circular glass tube, open at both ends, has a radius r and a length L. The axis of the tube lies along the x-axis, with the left end at the origin. The outer sides are rubbed with silk and acquire a net positive charge Q distributed uniformly. Determine the electric field at a location on the x-axis, a distance w from the origin. So first, we should identify the variables. R is the cylinder's radius, L is the cylinder's length, x is the distance of an arbitrary ring from the origin. The change in x would be the width of that same ring, and w minus x would be the distance from the ring to the observer location. And the observer location is on the cylinder's central axis. So basically each ring will make a contribution to the net electric field. So fundamentally we have to start by finding the electric field, and this is the equation for the electric field for a ring. And it's important to note that z is along the axis. So the change in electric field at the x-axis is equal to this quantity, and we substituted w minus x, which is the distance from the ring to the observer location. So we basically plugged in this variable into the formula you saw on the previous slide, and this is the final result simplified. Now, since this is the change in the electric field, we must find simply the electric field. So we take the integral, and the bounds would be x equals 0 and x equals L. Now to simplify the integration, we substitute u equals w minus x squared plus r squared, making the integration easier, which results in the final form as indicated here. So the key to this problem is understanding that the cylinder is a series of concentric rings, which allows you to use the electric field formula for rings. And this concludes the tutorial.